Okay, so we want to quickly review what happens if you have something other than just x or theta or t in your problem. For instance, twice the cosine of 3t minus 1 equals 0. Okay, so we're going to solve this just like we did before. The cosine of 3t equals 1/2. And where is the cosine equal to 1/2?
Pi over 3.
Okay, so 3t equals pi over 3 plus 2 pi n. And 3t equals, where else is it equal to positive 1/2? 5 pi over 3 plus 2 pi n. Now, I don't want 3t, I want t. So we're going to multiply both sides of this equation by 1/3. Okay, so when we do that, we get, first of all, t equals pi over 9 plus 2 pi over 3n, and t equals 5 pi over 9 plus 2 pi over 3n. Bless you. All right, now that would be all solutions. Let's see what we might have to do if we are restricted between 0 to 2 pi. Okay, so obviously if we are restricted between 0 to 2 pi, we know that t could be pi over n, or pi over 9. Okay. What if n is 1? For n equals 1. We would have pi over 9 plus 2 pi over 3. Okay, so that's the same as 6 pi over 9. So we'd have pi over 9 plus 6 pi over 9. And that equals 7 pi over 9. Okay, we're looking between 0 and 2 pi. I want all of the solutions between 0 and 2 pi. All right. What is 2 pi in terms of if 9's the denominator? 18 pi over 9 is 2 pi, right?
Yes.
Okay, so we need to stop when we get above 18 pi over 9 for the sum. Okay, if n is 2.
But where did you get 6 pi over 9?
That's 2 pi over 3 converted to ninths.
Okay.
Did I
Added them because...
It's plus this for different values of n.
All right.
Okay. So if n is 2, we have pi over 9 plus 12 pi over 9. And that equals 13 pi over 9.
What are you doing with the 2?
I multiplied it times this, because 2 pi over 3 is the same as saying 6 pi over 9n, right?
Yes.
Okay, so for this one, n is 1. Then I multiplied by 2 and got 12 pi over 9. Okay, let's see what happens if we multiply 6 pi over 9 by 3. Pi over 9 plus 3 times 6 pi over 9 is 18 pi over 9. Okay, that's already going to take me over 2 pi, so I'm done for that one. Okay, same thing over here. We have for n equals 1. Okay, we're going to have just t equals 5 pi over 9 when n is 0. When n is 1, we're going to have 5 pi over 9 plus 6 pi over 9, which is equal to 11 pi over 9. If n equals 2, we've got 5 pi over 9 plus 12 pi over 9 equals 17 pi over 9, and that's so close to 2 pi, I know I'm done. So we've got 6 solutions here. Here, 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 and here. Okay, so we only do this if you're restricted between 0 and 2 pi. No restriction, then you can just leave it as pi n, pi over 2n, however it works out. All right? Okay, we may have to solve using inverse functions, and that's normally going to occur when it's a value that you don't know. It's not a unit circle value that we've learned. So an example of that, if we had the secant squared x minus twice the tangent x equals 4. What do I need to do here? Move the 4 over. Anything else? Okay. We need to use an identity. We don't want secant squared and tangent. Since tangent's linear, we'll rewrite secant squared in terms of tangent squared, which is 1 plus tangent squared x. I think this is almost the same as the one we did earlier, isn't it? Minus twice the tangent of x minus 4. So we have tangent squared x minus twice the tangent of x minus 3 equals 0. Fairly easy to factor. Tangent of x and tangent of x, we have a minus 3 and a plus 1. So if we set each one of these equal to 0, we can work with this one. The tangent of x equals negative 1. So what is x going to be here? Okay, now remember, we're told to use inverse functions. And when we use inverse functions, tangent is restricted between negative pi over 2 and pi over 2.
Wait. Where?
Oh, okay.
It's between where?
Is it?
Not 7 pi over 4,
It's negative.
negative pi over 4 plus pi n. Okay, because we were asked to use inverse functions, and inverse functions have those restrictions.
How about positive?
This was negative 1.
And there aren't any others because it's in that restriction.
Well, in answering the question, our first angle has to be here, but this would catch every other one.
Okay, yeah.
Okay. All right, now, do we know an angle whose tangent is 3? I don't. So this we can rewrite as x equals the arctan of 3 plus pi n. All right, let's say we have 4 times the tangent squared of x plus 5 times the tangent of x equals 6. So first thing, we'll just move our 6. So we're going to have to factor this. And I need the factors of 4 and negative 6 that when I add them together would be 5. Okay. Will that work?
8 negative
Okay, so if we use 4 times the tangent plus 2 minus 3, yeah, that'll work. So here we get that either this equals 0, so the tangent of x equals 3/4, or we get that the tangent of x plus 2 equals 0, or the tangent of x equals -2. Do we know either one of those?
No.
No. So, if we think about this one, we've got x equals the arctan of 3/4 plus pi n. Here,
Pi and because of the restriction, right?
because tangent has a period of pi.
Right.
Okay. Here you'd have x equals the arctan
Negative.
of -2 plus pi n.